Welcome. Today we want to look at the redox reaction. In a redox reaction, we don't require an indicator. We just titrate, and the two reactants, once the endpoint is reached, the color changes without using an indicator. You are provided with the following: solution Q containing 9.8 grams iron salt. The iron is called, this is the iron. You can see the formula. Although it is called ammonium iron 2 sulfate. Ammonium iron 2 sulfate. Dissolved in distilled water and made up to 250 centimeters cube. That's where the key point is. 9.8 grams was dissolved to form 250 centimeters cube solution. So this mass is in this volume. Very important. Solution B is acidified potassium manganate 7. Solution K is dilute sulfuric acid. Procedure. What are you required to do? You are required to determine the molarity of solution B. Let us look at the procedure. Pipette 25 centimeters cube of solution Q into a conical flask. Add 10 centimeters cube of dilute sulfuric acid into the conical flask. Fill the burette with solution P and titrate it with solution Q until the pink color persists. Record the values in the table below. I want us to use 24.0, 0.0, 24.0, 24.0, 0.0, 24.0, 24.0, 0.0, 24.0. I always like to use one decimal place. So let us, next question is calculate the average volume of solution P used. The average volume of solution P used. So the P used is, so the average is 24 plus 24 plus 24. We divide by 3 and the answer is going to be 24.0 centimeters cube. Those are the marks a student should not fail to score. Calculate the concentration in moles per liter. Whenever you are asked, calculate the concentration in moles per liter. That means molarity. So whenever you hear, calculate the concentration in moles per liter. Moles per liter means molarity. So we are asked to calculate the molarity of solution Q. The RFM is 392. The RFM of Q is 392. So, but we know, how do you calculate moles? Let us use this triangle. Always you must know these formulas in your head. Moles, mass, and then RFM. We have already RFM. We want to calculate the concentration of Q. What is Q? You go back to what you are provided so that you can get. Q is a solution containing 9.8 grams prepared to form 250 centimeters cube. So it means we are going to use this mass, we use this RFM, and then we will get the number of moles into 50. The number of moles into 50. So moles in 250 centimeters cube. Solution Q is given by mass over RFM, which is going to be 9.8 divided by 392. This one is going to give us 0.025 moles. So this is the mass, this is the number of moles in 250 solution Q, right? But the question is asking us to calculate molality. Molality is the concentration in moles per liter, moles in 1 liter. So 250 is not a liter, therefore we want the number of moles in 1,000, which is a liter. We ask, if 250 centimeters cube solution Q contains 0.025 moles, what will 1,000 centimeters cube solution Q contain? Yes, so 1,000 times that is 1,000 times 0.025 divided by 250. This one will give you 0.1 capital M, and that is the molality. That is the molality of solution Q. Or let us use another, we can use another way. There's another triangle I've always been using. There is this triangle here. Because we want to calculate molality, we have been given the RFM, mass, which must be in grams per liter. Mass in grams per liter. Therefore, molality, because we want to calculate molality equal to mass, which must be in grams per liter. Mass in grams per liter divided by RFM. Divided by RFM. But the mass we have here, is the mass in 250. But we want mass in grams per liter. This is not a liter, this is 250, so we want mass in 1,000. So for us to use this formula, we ask ourselves that 250 centimeters cube contains 9.8 grams of that salt. 1,000 centimeters cube, that is a liter. Now, grams in 1 liter will contain how many moles? So it is 1,000 times 9.8 divided by 250. This one is going to give it at 9.2 grams in 1 liter, right? Now we have mass in grams per liter. RFM we were given, therefore we can get molality. Therefore molality is equal to 39.2 divided by 9 divided by 392, which will give us 0.1 capital M. Calculate the number of moles of iron 2 ions solution Q. Remember, we pipetted 25 centimeters cube of solution Q. So we can now get the number of moles in 25 solution Q, because now we know the number of moles of Q in 1,000 in a liter. So you must always go back to refer to what you have been given. Now we have the number of moles of Q, which is, this is the number of moles in 1 liter. We will ask, what about 25? Because we were told to pipette 25 of solution Q. So the volume we used is 25. 1,000 centimeters cube solution Q contains 0.1 moles. 25 centimeters cube solution Q will contain how many? 25 times 0.1 divided by 1,000. That one is going to give us 0.0025 moles. 0.025 moles. Given the equation for the reaction, so the permanganate reacted with the iron according to this equation, we can see the ratio is 1 to 5. Calculate the number of moles of solution P. Remember, this is solution Q and this is solution P. So this is the reaction equation. Therefore, we can clearly see that the manganate, the ratio is 1 to 5. But we have the number of moles of the iron from here. we have the number of moles of the iron solution Q, which is 0.0025. So we will say if 5 has this number of moles, what about 1? So that clearly shows you that we are going to get to a 50. Number of moles of the manganese is 1/5 of this. So it is 1/5 times 0.0025, which is equal to 0.0005 moles. Calculate the molality of solution P. The molality of solution P. Now, we have the number of moles of solution P that was used. What was the volume of solution P used? You go back and check the volume you used. Solution P, we used 24 centimeters cube. 24 centimeters cube reacted with 25 Q. 24 centimeters cube of P reacted with Q. Therefore, the volume is this. This is the number of moles we have gotten. Now, 24 centimeters cube solution P contains this number of moles, 0.0005 moles. Molality is in 1,000 centimeters cube solution P will contain how many moles? It is 1,000 times 0.005 divided by 24. This one will give you 0.0208.